Well, hi everyone, my name is Etienne Ricardes and I'm here to present Project 2B, Heredity. And first of all, the first thing we must ask ourselves is the goal of the project. The goal is to infer the probability distribution for whether any person will exhibit the trait in question. The trait is a function of genetics, so we must ask ourselves, what do we know? Well, first we know this Bayesian network that shows how the causality between the number of genes that the mother has and the number of genes that the father has in if whether this mother presents the trait or whether this father exhibits the trait, and also this affects whether the child presents or no genes and also exhibits or no the trait. Fine. Then we also know the unconditional probabilities and also conditional probabilities that are on the left side of the screen. The unconditional probabilities is the probability whether you can have 1, 2, or 0 genes. The conditional probabilities is whether you exhibit the trait if you have 2 genes or 1 genes or 0. Also, we know that this gene can mutate in 1% of the time. Also, we know these datasets. We have families, for example, the first one, Harry, James, and Lily, and we notice that we have incongruent datasets. We know James presents the trait, Lily does not, and we also know Harry has as mother Lily and as father James. We must, in function of that information, to infer whether Harry will have 0, 1, or 2 genes and whether he will exhibit the trait or not. This is, in part, easy because we know James exhibits the trait. So we can go a step back and ask ourselves, what's the probability that James has 1 gene or 2 genes or 0 genes? We know that because he exhibits the trait, it must at least has 1 gene. And the same applies to the case of Lily. Given this information, if there is no parents, in the case of James and Lily, we can use unconditional probabilities to calculate their distribution probabilities of whether they have or not 1 or 0 or 2 genes. But in the case of Harry, we must use conditional probabilities because we only know the name of their parents and we also know just if their parents has exhibit or not the trait. In this calculation, using the conditional probabilities, we must take care on the number of the genes of the parents, whether they have or 1 or 2 or 0. We also notice that this isn't a solid data, it is just an inference, and we also must take care on the probability that we are calculating. For example, if this person is in 1 gene or 2 genes or neither those two. We also must take care on whether the person is in half trait or not. So we must quick go to the code because of the time, and here is the first one. Let me just calculate the other family. This is the second family, Arthur, Charlie, Fred. As I was saying, you can notice the probabilities that one person exhibits or not the trait because we have that information on the dataset. So thank you, that's it, and goodbye.